Title your notes discriminant. All right, discriminant. Actually, we should put the discriminant. My bad. Put the discriminant here. That's the title. That's more appropriate. The discriminant. Now, the word discriminant has a kind of a familiar word in it, right? Okay, can you guys kind of see the word that's indiscriminate? Discriminate. You guys have been trained to use it, to see the word discriminate in a bad light. Discrimination. That's when we make a distinction between types of people and we treat people differently based on their skin color, ethnicity, and so on. That's a bad form of discrimination. But discriminate, the word itself just means to make a distinction between two types of things. So not all discrimination is bad. You and I discriminate between good and evil every day. You and I discriminate between good food and bad food. We make distinctions all the time. So not all discrimination is bad discrimination. Some discrimination is bad, but most of it's not. Now, the discriminant is a tool in mathematics that we use to discriminate what trinomials are factorable versus which ones are not. About 5 minutes ago, I asked you to factor this trinomial, and we found out as a class we can't. But rather than wasting time by trial and error, and finally figuring out you can't factor it, there's a tool called the discriminant that allows us to see whether we can factor a trinomial or not. So it's quick. Okay, and that tool, the discriminant, is on your notes. I want you to write b squared minus 4ac. That's the discriminant. Write that down. b squared minus 4ac is your discriminant. Yeah, you may have seen this before from the quadratic formula we're going to get into later. But the b and the a and the c come from the standard form of a trinomial. Remember, whenever we have trinomials, they're always in this form, ax squared plus bx plus c. Right? That's where the a, b, and c come from. So on your notes, going to write standard form of a trinomial. Standard form of a trinomial. So that's where the A, B, and C come from. In other words, your A is there, your C is there, and your B comes right there. Okay. When you're dealing with the trinomial. Well, how does this tell us whether it's factorable or not? What goes on? Does fireworks go off? Does a bomb go off? Well, how does this tell us whether a trinomial is factorable or not? That's what I'm about to get into right now. B squared, b to the second power minus 4 times a times c. How does that tell me whether a trinomial is factorable? How does that allow me to discriminate between factorable trinomials versus unfactorable trinomials? Well, this is not as exciting as you were expecting, but stay with me. All right. Here we go. How does this discriminant allow us to discriminate is the question. So, here's how. We'll write b squared minus 4ac. There's two possibilities. We'll draw two arrows. You're on the right track. Watch. Watch this. If we do b squared minus 4ac and we substitute b with whatever b is and a with whatever a is and c with whatever c is, there's two things that can happen with this. There's two directions. Either it results in a perfect square or non-perfect square? Now, when I say perfect square, you should remember what a perfect square is and a non-perfect square because we did Pythagorean theorem about a month or two ago. So if I substitute A with A and then C with C and then B with B here, and if it becomes a perfect square, what is a perfect square? Can someone give me an example of a perfect square? 100. Because look at the square root of 100 is what? 10. What's another example of a perfect square? I have them listed by my Christmas tree. Isn't that beautiful? Look at it. It's like a perfect Christmas tree with a perfect square right behind it on the board. So those are all the perfect squares. Rad 4 is 2. See, these are perfect squares. So, if b squared minus 4ac becomes 100 or 4 or a 9 or a 16 or a 25, then the trinomial is factorable. Put then factorable. In other words, we wouldn't be wasting our time trying to find the factors. See, if you do the b squared minus 4ac and it turns out to be a perfect square, then it's factorable. If it's a non-perfect square, it's not factorable. Simple as that. Not that crazy. Okay. Let's try it with example 1. I'm going to write the same one for warm-up. I'm going to write example 1. I'm going to write is x squared plus 3x minus 2 factorable? Is it factorable? You and I already know the answer, but I'm going to show you the answer using the discriminant. This is example 1 now. Right, Carlos? I trust everybody got this. I'll post this video on Google Class. In case you don't have it. All right. Is this trinomial factorable? Again, you and I already know it's not. But let me show you through the discriminant why it isn't. Ready? So let's write the discriminant. B squared minus 4ac. All right. Let's first identify our A, B, and C. What is the A value? Close. So A, let's go back over here. A is whatever's in front of the x squared, right? Right. So in this case, A is going to be 1, right? There's an automatic 1 coefficient of the x squared. So I know I'll replace A with 1. What's my C value? Very good. I'll replace C with -2. And my B value is 3. Okay? So let's do it together now. You'll see what happens. Ready? So we got 3 squared minus 4 times 1 times the -2. All right, let's follow Aunt Sally. Remember order of operations from Math 1 or even pre-algebra. Aunt Sally says to do the exponents before you subtract or multiply. So 3 to the second power. What is 3 to the second power? 9. Remember, be careful. This is not 3 times 2. This means 3 times 3. So I got 9 minus 4 times 1 times the -2. Okay? Moving right along. Should I subtract the 9 and the 4 or multiply the -4? No, we've got to multiply first, huh? What I like to do is I just like to put this as a plus -4 just so it's clear in my mind that I'm dealing with a -4 here. So -4 times a 1 will be a -4. Good, huh? Negative, negative, that becomes an 8. 9 plus 8 is 17, huh? Now, is 17 a perfect square? No, it's not. So notice the two roads. Look at the two roads. If b squared becomes a perfect square, then it's factorable. If it becomes a non-perfect square, it's not factorable. So this went down the road of a non-factorable. Okay, if you take the square root of 17, that's not a perfect square. It becomes an infinitesimal. So I'm going to write non-factorable. This is why it was a waste of time to even try it when I offered the 10 stamps earlier. Forgive me. Would like to answer that before I answer it? She wants to know why I put 9 plus negative 4. Right here. How did this turn this running? Go ahead. Okay, that's 9. So that explains the 9. So 3 to the second power is 9. But why plus negative? So I don't get signs confused. In other words, minusing the 4 and a plus negative 4 mean the same thing. Okay. So, no, here's a better way to say it. Here's how. Subtracting a 4 and adding a negative 4 mean the same thing. That's how to better say it. Okay. So in other words, let's say 1 minus 2, that's the same as 1 plus negative 2, huh? So that's all I did. You added 3 squared minus 4, so I changed this to that. It means the same thing. Okay. The reason why I like to do that is because when you multiply, you want to make sure you multiply to negative 4. If you just have a subtraction in front of the 4, if this is like a negative 4 times a 1 times a negative 2, for instance, like right here, if I write it like this, there's a tendency in students to just say 4 minus 1, right? In other words, there's proneness to mistakes at this point, knowing that this is not this is a negative 4. So I like to just make it this is a negative 4. So and then they go on from there. But you don't have to. If you're not comfortable doing that, you can keep that as a subtraction. But just be careful when you get to the end of your expression. All right, so it's not factorable. Cool. One more example. One more. Actually, 2 more. Here we go. Example 2. Is x squared minus 3x plus 2 factorable? Example 2. Is x squared minus 3x plus 2 factorable in this case? Okay, let's find out. Let's see. So let's use our discriminant. The discriminant is b squared minus 4ac. Cool. So let's see. A is going to be 1. That'll go right there. C is 2. That'll go there. B is negative 3. That'll go right there. Right? Right, Constantine? Are you with me? Here we go. Here we go. Negative 3 squared minus 4 times 1 times 2. Again, here's my little quirky thing I like to do. I like to put the plus negative just so I know it's a negative 4 I'm dealing with. All right, here we go. So negative 3 to the second power, that's going to be positive 9, huh? Yeah. because negative 3 times negative 3 is positive 9, plus a negative 4 times 1 becomes negative 4, and then a 2. So we got a 9 plus a negative 8. What does that become? 1. Is 1 a perfect square? It is, huh? If I take the square root of 1, you get 1, huh? Because 1 times 1 is 1. So this is factorable. I wouldn't be wasting my time, in other words, trying to find the factors of x squared minus 3x plus 2. I know they exist. So I can be confident that they exist. Let's find them right now, because we're on it. X and x here. Well, what'll make a positive 2 but add up to be a negative 3? Negative 2, negative 1, I think is a 1. Right? Negative times negative is positive 2. If you add negative 1, negative 2, it becomes a negative 3. Here's your factors. So notice how it was possible, so then we proceed to go and find them in earnest, knowing that they exist. Yes, Ms. Barcenas. Perfectly said. This would be very useful with bigger numbers, the discriminant. Very useful. That's actually why they have it. I start off with very simple ones just so you can see the logic of it all.
So when it's factorable, the answer can be true to the expression, right?
Well, the factors will be the two binomials. In other words, let me put it this way, Castro. If it was a perfect square, then I know that these two binomials exist somewhere in reality. I just got to find them. Look at the example 1. This is a non-perfect square, so I know that it would be a spectacular waste of time trying to find the factors of this trinomial because they don't exist. So the discriminant is just a tool. That's all it is. It's just a tool to figure out whether a trinomial can be factored or not. It just helps us discriminate between factorable or not factorable trinomial. That's all it is. That's all I'm teaching right now. Right? What do you guys think? No biggie, right? What am I going to say? All right. Tomorrow, coming to a theater near you. Right, stay tuned. How do we handle, look at x squared plus 3x. Look at this example 1. What if we had an equation? How are we going to solve that equation if it's not factorable? See, look at example 1 was not factorable, right? That's what we got for example 1. What if we had an equation like this, and I ask you to solve the equation and it's not factorable? That's what I'm going to cover tomorrow. What do we do at that point? Again, I'm setting you up. It's a big setup. Like Mr. Miyagi and the Karate Kid. Remember yesterday? Did I show you that film clip, by the way?
Yeah.
It's a great film clip. I'm done for the day. Work together or work solo. There's a brand new assignment on solving quadratics, which is assignment 16. We're coming down to our last assignments. Let's get them done. Grab your Chromebooks. I'll play some Christmas music. And I'll be walking around the hall. Get busy. Some of you are way behind. So now I've got I guess he's checking it twice. You can find out whether you're 9 or 9. Right on?